We're on lesson 6 of chapter 8, which we're going to solve systems of equations by graphing. First, we're going to graph a system of linear equations to solve a problem. Then we're going to solve systems of linear equations by graphing. We've solved systems of equations before, but we haven't done it by graphing yet. And for many people, when we graph systems of equations, it makes a lot more sense to them. Remember, systems of equations can answer a problem like this: determine when the planes will travel the same distance. For this situation here, we have two planes taking off at different times, but at the same speed. So for this first one, it took off here and is traveling at this speed. This green one took off later and is traveling at the same speed as this one. So when is this one going to catch up to this one in distance? And since they're traveling at the same speed, you know that's going to be a trick question. This one's never going to catch up if they're traveling the exact same speed. It's forever going to be this far behind. That's an example of a system of equations with no solution. If we look at this, we have y equals 2x plus 4. Then we have y equals 2x plus 1. This y is always going to be 3 behind that y because it started 3 behind it. And the slope is exactly the same. For this example, we have two planes taking off at the same time and the same speed. So this line actually represents two planes. So what would be the solution for this? When are they going to be the same distance as each other? That's also a little bit of a trick question because they're always going to be the same distance as each other because they took off at the exact same time and they're traveling at the same exact speed. So this would be an infinite solution problem, meaning that there's always going to be a solution on that line. An example of that would be y equals 3x minus 5, slope and y-intercept. And this equation has the same slope and the same y-intercept. So there are going to be two lines right on top of each other. Our third situation is one plane takes off first, so this brown one here, but the second plane has a faster speed. So this green one, even though it took off later, has a faster speed. Now we can solve this because this green one is eventually going to catch up to the brown one, and the point where they are exactly the same distance is the point we're looking for. So this one has one solution at 4 and 6. An example of that would be this: y equals 1 times x plus 2. 1 times 4 is 4, plus 2 is 6, 6 and 4. Or y equals 1.5x plus 0. 1.5 times 4 is 6, plus 0 is 6. So in this example, they would both have a solution of 4 and 6. In this example, they are both the same distance at this point right here. So let's solve a real-world problem first. It says a fishing boat leaves the harbor traveling 16 knots or nautical miles per hour. After it travels 40 nautical miles, a Coast Guard cutter follows the boat, traveling at 26 knots. After how many hours will the Coast Guard catch up with the fishing boat? What distance will the boats have traveled? So the first thing I want to do is make an equation for both boats. I see that the fishing boat is traveling at 16 knots per hour. So that would be a slope of 16, so 16x. Then it gets a 40 nautical mile head start, so that would be 16x plus 40. So here's my equation. Y equals 16 times the number of hours plus 40. The Coast Guard boat, on the other hand, is traveling at 26 knots, but it doesn't get that 40-mile head start. So that would be y equals 26 times x. Like usual, we can make time our x-axis here. This is measured in hours here, so we'll say hours. And looks like their speed is measured in knots, which is nautical miles. So we'll say nm for nautical miles. So that's the distance. So if you look at the first boat here, the fishing boat, it's traveling at 16 knots or 16 nautical miles per hour. So since that's a pretty high number, I'm going to count by 10. So we'll have 20 here, 40, 60, 80, and 100. We see that this first boat has a 40 nautical mile head start, meaning that when the second one takes off at 0, the first one's already going to be at 40. So if we do the fishing boat here, the slope is 16, so we go 1 over would be 56, 2 over would be 72, 3 over would be 88, 4 over would be 104. This Coast Guard boat, on the other hand, has a 40 nautical mile distance to make up, but it's traveling at a rate of 26 knots. So it starts at 0, and then a slope of 26. So 1 would be 26, right about here. 2 would be 52. See how it's catching up? 3 would be 78, and 4 would be 104. Notice I put that green dot exactly over the purple dot. After 4 hours, this boat has traveled 104 miles. After 4 hours, the Coast Guard boat has traveled 104 miles. We can plot out lines to show that then. This line's not going to be perfect, as you can tell. We have this one here. And that shows that they meet up exactly at 4 hours. So anytime after 4 hours, this Coast Guard boat, this faster one, is actually going to be traveling farther. So we can answer our questions here. After how many hours will they catch up to the fishing boat? Well, at 4 hours, they are exactly the same. So we'll say 4 hours. And then what distance will the boats have traveled? We said that was 104. So we'll say 104 nautical miles. Now we can solve systems of linear equations by graphing. We have these two equations here. We have negative x equals negative 1 plus y. When we have a problem like this, we want to get it into slope-intercept form to graph it. So that means we want to solve for y. So if we solve for y, we get rid of this negative 1 by adding 1 to both sides. And that would give us negative x plus 1 equals y. So that means my y-intercept is 1, and my slope is negative 1. So we start at my y-intercept at 1, go with my slope over 1, down 1, and keep drawing that out. And once I've done a few of those, I can make my line. So we can plot this line out to follow this same exact slope. Draw it out both ways. There we have it. Now we need to turn this into slope-intercept form. We could subtract x from this one too. So that gives me y equals negative x plus 4. So that means that my y-intercept is 4 and my slope is negative x. So we go 4 up for my y-intercept. The slope is over 1 and down 1. So I can graph my lines that way. We'd plot this line. Extended path both directions. And then what do we notice? Well, we notice that this line is not any closer up here than it is down here. They're exactly the same. So these lines look very parallel. That means that there is no solution. And that makes sense. Look at the slope for both of these. I see negative x, I see negative x, and they have different y-intercepts. Meaning they start at different locations, but they have the exact same slope. So it would make sense that there would be no solution. Here we have negative x plus y equals 8, so we could add x to both sides. So we have y equals x plus 8. We have y minus 8 equals x, so we could add 8 to both sides here. That gives me y equals x plus 8. You'll notice that these are the exact same equation. They start at the same point and they have the same slope. So I only need to graph 1 on this one. So we'd go up 8 to the y-intercept and we'd plot a positive 1 slope. We can draw our line. And since the slopes are exactly the same, I can just leave one line out there because this line will be exactly on top of this line. And since the solutions are where the lines meet, since they are exactly on top of each other, we would say infinite solutions.